all I'll tell you about our company is it started in Germany about 100 or so years ago. So it's a very well-established company that's been around providing solutions forever. Came to the U.S. maybe 10 years ago. Primarily, what we do is make self-leveling compounds and patching repair materials to fix concrete, wood, whatever kind of substrates we're going to talk about here today. So this is the presentation, and it's all about why do we even prepare any of the subfloors? What's the whole point of why we're here today? The big point is you don't often run into this. Now, it's mostly what you do, new construction? Is it the vast majority? Okay. All right, so then we're going to try to get away from that. So if you design this and you're not going to run into that, your new slab, whether it's precast or cast in place, you may have deflection issues. You may have just unevenness. So how do we get your new slab to get flat and smooth enough to give you that kind of result? So that's what these products that we manufacture do. So yes, you do have floors like this in the industry. We make self-leveling cement. So what's different about self-leveling versus regular cements? Regular cements, you can go as thick as you want, but primarily you can't go less than 2 inches. If you go less than 2 inches, they can crack, curl, and fail, not bond. Self-leveling cements, you can go down to pretty much 0. So when you have a deflection issue and you're going from 0 to 2 or 5/8 or whatever, that's where self-leveling comes in, and that's why you can't use concrete. So we're going to talk about the common substrates that you're going to run into, some of the conditions and problems, cures, and how we test for everything. Common substrates. So out of these, you probably are going to, let me see concrete. I don't even see concrete in there. There should be one missing here. That's the most common one. These are all the other ones. I don't know if, do you ever renovate on multifamily, or it's all just, again, mostly new?
Not a whole lot, no.
All right, well, let's say you want to renovate something down the road. What can you go over with these types of products? You can go over epoxies. You can go over ceramic tile. Maybe the tile is outdated. Maybe you don't like the color, the look. You can go over stones, quarry tile. You can go over VCT, and in older communities like ours, VAT. We'll talk about how. This is a super common thing. You have existing flooring that gets removed and it looks like this. Can we go over the adhesive residues? What can we do? What can't we do? Sometimes you get outdated terrazzo and you want to cover it, which is a shame because of the cost. You're probably not running into a lot of wood. I would imagine if you're doing multifamily, you're going to run into gypsum for sound control and fire ratings. So if you have, say, a sprinkler leak or a roof leak and something happens to the gypsum, how do we repair that? Unless you're going to do a elevator floor, you're probably not going to run into metal very much. And what you do, I don't see raised access being a lot in the future. So the most common thing that we're going to run to, all of us, is standard concrete in the construction industry. Standard concrete and absorbent concrete, or I'm sorry, lightweight concrete. Lightweight concrete is defined by its lighter weight than this. Lightweight concrete maybe is about 65 pounds per cubic foot. It's about double that. How do you get lightweight concrete? Is you put lightweight aggregate in it. So this is a cross section of the aggregate. It's kind of like, let's say, a lava stone. So it's filled with a lot of air voids, which gives it the lightweight, but it also is going to cause other problems for us as far as retaining moisture and things like that. But these are the two most common things that we run into. And I'll probably keep falling back onto, to make your life as easy as possible, if you can always get to this, clean concrete, a blank substrate, this should always be everybody's goal. The moment we start talking about all these things that we can cover and go over, even though you can, the moment you start introducing other things, it's just another component in a system that can fail. So if you have nothing between the original slab and any kind of adhesive or patch, then the likelihood of there being a problem is almost none. So this is always our goal, is to go over this. Standard concrete. Commonly encountered substrate conditions. So for concrete, what are you going to see? I would think this is a common thing. Precast for you. A lot of specifications I see, and if anybody wants to chime in, if you know what yours is, when you have precast, a common specification is to cap that with a 3/4 of an inch of a self-leveling product, or you cap it with a 2-inch concrete capping slab. Issues with a 2-inch concrete capping slab is it has to be a minimum of 2 inches. and it could crack and it could curl. It could maybe not bond. And the reason you're going to self-level over a precast plank like that are all these joints. And sometimes those joints are nice and flush. Sometimes those joints are out of whack as much as an inch. So I would imagine this is something you run into a lot, and it's a situation where you won't need concrete. You're going to need self-leveling cement. The other thing for you, if you're doing cast in place, I guess people could overwork it. You could have some variations in elevation. That'll usually come into play with the precast joints. Cracked and spalled is kind of common with concrete. Deflection and slab curl are probably relatively common for you. Do you run into those in the industry? It happens. Sometimes you just simply can't avoid it. So again, if you have a deflection, let's say like this, you might have from that low point to the high point, it might be 3/4 of an inch. And over at the high point, you might be 0. Concrete, standard concrete cannot fix that. So all these engineered cements are able to do these kind of repairs. You don't typically see a lot of reverse curling, but the way you get this, to give you an idea, imagine concrete is analogous to a typical kitchen sponge. You take a typical kitchen sponge and saturate that with water and put it on your countertop and then let it just naturally dry. If we've all seen that happen, what happens is the top of that sponge just starts to dry, but the bottom and the center is soaking wet. So a concrete slab can do the same thing, and your sponge will curl just like concrete will curl. You do work everywhere, so you can have frozen concrete, you can have rained on sunbaked, you can have all that kind of stuff. And we'll tell you how you could repair that. So this, for you, yes, you can go over stone, ceramic tile, quarry tile. When it cracks, oops, sorry. When it cracks like this, that could be an indication that you have movement. When you see cracks like that, it can be movement. Sometimes crack can be caused, this is showing thin set, not having good coverage over the back of the tile, bonding to the substrate. So once you have movement, you don't have good bonds, you could have cracking. You could have tiles that are uneven. If you have a tile installation in your lobby in your multifamily, and you see a lot of that, I'm sure you're not going to accept it, but if there's no option to rip it out and you wanted to cover it, yes, you can cover that if it's down tight, well bonded. When you see cracked tiles, we have to ask ourselves why, what happened, what caused it. Was it a bad installation? Is it movement? Is it deflection? Is it settlement? Contamination, I've seen where they set ceramic tile on top of old carpet adhesive. Nobody would know that. If you tried to pour on top of the ceramic tile, the tension might be enough to rip the tile off of the ceramic or off the old carpet.
So why would anyone ever go over old tile in such a, I mean, if there's such an unknown underneath?
Great question. I think you're crazy to do it, but sometimes what happens is it's not an elevation issue. They have room to gain, so they don't care. There's a cost associated with ripping out 5,000 square feet of tile. And then when you take out the tile, you have all the thin set underneath it that may or may not be good. We're doing a hospital in Pennsylvania now where they took out the tile and they took out the 2-inch mud bed. When you start doing the demo and you're doing all your drawings, the architect on that job just has remove existing tile and mortar bed down to concrete. Well, as people are bidding that project, how do they know how thick the mortar bed is? So the problem that they're having that you would inherit as the architect is one guy bid, I will tear everything out and replace it with an 1/8 of an inch material. And another guy who's a ceramic tile expert is going to know there's a 2-inch mud bed. His price is to put 2 inches of stuff back. It's here. The 1/8 inch guy is here. He gets the job because it costs less. Now you inherit this guy and all the problems that are now causing you because now you have to choke up, somebody has to choke up another 60 grand to fix 13 bathrooms or something. So you can go over it, but sometimes you open a can of worms when you do so. Adhesive residue, this is probably the most common thing that we all run into. You have an existing floor covering that's down and nobody likes it for whatever reason, or it needs to be abated and you need to get rid of it. But once you get rid of, I'm going to learn how to use this. Once you get rid of all this carpet, you could be left with all this adhesive residue. So can we go over all this? Yes. The whole industry, the technology's changed. It allows you to go over a lot of things, but keep in mind, every time you let something like this, whether it's this, any of this stuff, the moment you leave something between the pads or the flooring and the concrete, that thing could be the weak link in the chain. So if a flooring contractor installs stuff on top of this adhesive residue, product's fine, the installation's fine, The problem you could have is this adhesive residue could separate from itself, or it could separate from the floor. So whose fault is that? Nobody's, but you now have a problem. So I would say with what you do, what are the finishes? A lot of carpet, a lot of vinyls, tile. Depending on the finishes, it's not like you're having a heavy rolling Hill-Rom bed coming into your hospital room and twisting with 2,500 pounds of weight. So you have a lot going for you with the usage you have. It's a lot of foot traffic and just people walking in and out. So you can get away with a ton and hopefully not have any problems. So terrazzo, you're not going to run into that. So yes, can you go over terrazzo? Without a doubt, you can. There's two types. There's an epoxy terrazzo and there's a cementitious terrazzo. If it's a cementitious terrazzo and it's a building from the 1920s, more than likely there's no vapor, it's harder underneath the concrete, so vapor's freely coming through your terrazzo. You don't like the terrazzo, you now want to cover it with some nice LVT. Well, the LVT all fails. Well, I never had a problem with the terrazzo, but now you have nothing but problems with the new floor cover. So if you're going over terrazzo, give us a call and just know that you want to know if it's epoxy or if it's cementitious. If it's epoxy, more than likely something in that system is already being used to control the moisture vapor. Otherwise, the epoxy terrazzo itself would fail. Wood conditions, you do like say 3-story wood frame, that kind of thing?
Yep, higher.
Okay, so every now and then you have those, and there's all kinds of woods that are out there now, and I don't know what you're specifying, but you may have a wood that's rated to be outside and exposed for 9 months, 6 months, or whatever. The chemicals that they put in that wood may inhibit the bond of adhesives or patch or something like that. So you may want to look into the wood that you're specifying is compatible with the finishes that are going to be going on top of it. If you just go with a standard everyday Joe Blow CDX, and that's OSB, exterior one graded subfloor whatever panel, you can put that down all day long. We've seen jobs where you put a product like this down, and before everything gets enclosed, the floor gets rained on. These edges, even though they're painted and sealed, if enough water is on there for a long enough time, that could act capillary action and suck in the water. So we've had jobs where they had this in a multifamily. They covered it with the self-leveling cement that we're talking about. Everything was bonded and stayed fine, but you could see every 4x8 sheet telegraphing through the self-leveling cement. What had happened was there was enough moisture for long enough time that these edges mushroomed just a little bit. Not enough that anybody could see it or be concerned about it, but it was enough that when the self-leveling was put on top, the self-leveling cracked. And if you walk on that joint, it would compress and the crack would tighten up. So in time, with that up and down, those joints are just going to start to get wider and parts and pieces are going to fail. So if you're using wood, we have to be hypersensitive of any kind of moisture. From what you're saying, you're not going to run into these weird panel products like they make a very inexpensive panel product is called, what is it, Terry? What's the thing I'm thinking? Quarter-inch Luan. Luan plywood could just be made and covered with silicone and just weird stuff for shipping from overseas to here. Those things could have bond breakers, kind of like if you have specialty subfloor panels. This I see primarily in schools, which I don't, and you guys have all told me you don't do. Can you go over hardwood? Yes, you can. I would say the biggest thing for you, if you ever have a wood condition where you have a wood substrate needing a concrete substrate, you have two dissimilar materials that can contract at different rates. If it's in somebody's living room and it never sees the light of day and the temperature's always constant, we could probably patch that and you'll never have a problem. If you take that same condition and you throw it in front of this window and the light's coming in every day and moving down as the sun is changing, everything expanding and contracting every single day, and it's doing so at a different rate. So the joint that you would have there would be a nightmare forever. Yeah.
So how does your product compare to gypcrete? Because typically that's what we're using in our wood job.
Yep.
We're always doing a layer of gypcrete for acoustical purposes primarily.
Yep. I don't see that you're going to change that either. I'd love for you to, but the reason you won't or won't be able to is to get for sound. You're looking at what an STC rating or an IIC with the floors,
Yep.
And you don't rate a product individually. You know, I think NRC is what you get for assembly. You don't rate individual products. So a company like USG that's a mammoth that will make the ceiling tile and all the drywall, they're going to spend tons, I mean, ridiculous amounts of money to do all kinds of testing. So they're going to test your assembly or you'll have assemblies to pick from, where it will be, if I need a certain sound rating, if I need a certain fire rating, I need X amount of this kind of gypsum on this kind of plywood on top of this floor joist or joist system with a drop ceiling of this kind of ceiling tile. So that gives you what you're after. So is their stuff any different or better than ours? No. Will our stuff burn? No. But they've done all the testing, and our industry hasn't done any of it. So I don't know the wisdom, other than a bunch of stubborn Germans don't want to tell you, I'm going to spend a lot of money to tell you cement doesn't burn. I think that's kind of how it happens. So where I don't see that changing for you. The other thing with what you typically do, if it's larger high rises, you're talking typically a lot of square footage, especially around here. So when you get a lot of square footage, people don't want to hear that these products are costing $3, $4, $5, $6, $7 a square foot. So gypsum primarily is known for its low cost. There's reasons for it, like you can't get gypsum wet. Like if you wanted to do gypsum early on in a project, to flatten all the floors, to make all your door jambs great, to make all your casework easy to install, and then you had one rain, you're shoveling everything out and you're done. We could do that. You can put our stuff in, and if it got rained on, it wouldn't make a difference. But the cost difference for the thickness that you need for your sound and fire rating, although we could do it, it's not tested.
So basically, they have a monopoly.
No, it's a different world. Pretty much what you do. For us, I could see us helping you out if they renovate some of these units. Like let's say after 3 years, they're going to come in and you're going to redo everything that you just designed 10 years ago. And when they do that, if I went back to the slide where they're ripping out all that ugly carpet, you would now have that to deal with. Well, now how do I deal with all this gypsum that now has my fire rating and sound control? How do I then cover that to make it look nice and smooth so I can put all these floors that you guys put down and make it look wonderful? That's where we would come in. Speak of the devil, that's the next slide. So everything I said, boom, right here. So what could happen with gypsum? Because gypsum is what we're talking about, you have to also keep in mind the way to install gypsum. Gypsum doesn't typically come in these little bags, 50-pound bags like ours. They come in these big 80-pound bags. They show up on site with these giant pumps that are outside. They have big sand piles and bobcats that take buckets of sand and dump them in this big hopper and mix everything together. When they do that, if they do what the manufacturer says, you get a certain compressive strength in the product. The way it was designed, that's what you get. If somebody had some ulterior motive to maybe make more profit and they wanted to throw a lot more sand in there and less product and more water, you could tweak the product like crazy, and then what you inherit is a very soft floor. So if you've ever walked into one of your jobs that was covered with gypsum and it's all soft and dusty and weak, you got something very inferior, and it may or may not have been by design. So if you run into that, can that be fixed? Yes, it can be fixed. That's where we would come in. So if something bad happens, by design or not, gypsum is typically softer. Gypsum is typically weaker. Gypsum will crack on top of movement, as with anything. You can get dusty and powdery. The biggest thing I would say for you as well is the dry time. Because of the inherent weaknesses, let's say, of gypsum, you can't do it early on in a project. What you have to do is wait till the end of the project and then bring it in. So what you get at the end of your project is you're out of money. The project's out of money, maybe. You're out of time, and all the units are already sold, and people are moving in the beginning of August, and you don't have any time. So it's this big fire drill, and everything has to get done. And what that means is if you did it early in the project, you don't have all that stress, and you could do the whole floor all at one time. But at the end of a project, because the whole floor is loaded with ductwork and drywall and everything else, now the cost to do any repairs go up exponentially, because now you have to take all the ductwork from this section and move it over to that section, and you're just moving around like chess pieces. So if you could do it early, fantastic. Our stuff, you can do it early. This stuff, you can't do it early. Contamination, a big plus with gypsum, it doesn't really, the way our self-leveling cements work is they get down into the pores of concrete. Like imagine concrete's like a sponge or a English muffin. We get into that really rough surface in the pores on a microscopic level, grow these little chemical legs, and we lock it in place. If you do it right, you could never separate us from what you're pouring on top of. Products like gypsum, you basically glue it to the floor. So you slather some gypsum on there and it just lays there. So because of that, you can go over, and there's no tensile pull. Other products have tensile pull, which isn't a bad thing. It's just a function of the product. Gypsum just kind of lays there. So again, if you wanted to slather a bunch of gypsum on top of adhesive residue, you probably can with some success. Metal floors, again, unless you're going to be doing an elevator, not much to talk about here, but you can go over metal floors. We've done coolers. I don't know if you'd have a cooler in a kitchen in a multifamily or something, but if you ever had to go over a cooler metal floor, you can do that. We usually run into this in elevators and MRIs in hospitals. Raised access, again, I'm not seeing, if you're going to go through the trouble of designing a raised access panel with access underneath it, why in the world would you cover it up and go over it? But if you want to, you certainly. So we'll talk about some of the problems and causes and cures and all that kind of stuff. All right, so the big issue in the industry by far is moisture. And we talk about moisture, we're not talking about rainwater or water from a lake or rain or anything. We're talking about moisture vapor coming up from the slab or through the ground, from the ground through the slab. So the biggest source of that is, of course, groundwater. So whether we're in Florida, Pennsylvania, Maryland, or Arizona, there's water in the ground and the vapor's coming up through it. Can we control groundwater so it doesn't affect us? Yes, we put a vapor retarder like a stego wrap underneath concrete and we don't have to worry about it. This would be more of a concern for you. So when you design your concrete mix and you have a water cement ratio of like a 0.4, 0.2 or something like that, that's what you need to have a good workable concrete. If you then say happen to do multifamily and you have the pump concrete to the 17th floor, that ratio is going to go out of whack because concrete needs to be wetter to pump it up to the second floor, the third floor, the 15th floor. So if you have very wet concrete that make it pumpable, now you have a lot of extra water that needs to come out of there. So it's very easy to say, well, hey man, we're on the third floor, we're never going to have a moisture issue with this concrete, but it's wide open, you pump it, you're going to have plenty of moisture in that concrete. And if that wet concrete gets rained on, that's environmental. Can you control that? You know, make sure the building's closed. You can't control floods or sprinklers. If you ever re-wet concrete after it's been cured for years, the capillaries and pores, everything's nice and small and tight. If it gets re-wet, it could take a year for a regular slab to dry out. You can't control if things flood or break. Hydrostatic pressure, I've talked about this for 20 years and I've never seen it once. So hydrostatic, I'm sure there's a picture of it. We'll show it in a little bit. But we'll get to that. So we kind of talked about a lot of these already. So causes for moisture, groundwater. This is what you're going to be using to fix it. So you might not have that on your third floor, your second floor, your 18th floor, but on your groundwater or on your ground floor, you're going to put some stego wrap down and pour your concrete. And as long as the concrete's drying out, you're fine. Because what this is showing here, an open slab system is concrete, soil, and Jesus, my hand's shaky. Could be more shaky. This is showing you don't have this vapor barrier right on that line. So the moment you put this vapor barrier there, those dark blue lines, the vapor cannot come up anymore. And so all you now have to worry about is your water convenience. So now the water that's in that slab, as long as you have enough time to let the water escape and dry out so you can put floor covering down, you're not going to have any problems. Environmental, I mean, this happens. If you pour your slab, you bring in some precast or you cast in place and it's multi-story, and after days and weeks, the stuff gets rained on, you're going to have puddles, you're going to have pools. It happens. And so what if it happens? How do we determine if there's a problem? Your flooring guys show up. This kind of stuff is occurring here, like we talked about. If you pump it, it's very wet, or if it gets rained on. So now we think there's a problem. How do we determine if there's a problem? We do moisture testing. This is what's been done forever. It's called a calcium chloride test. You put that on the concrete slab. ASTM tells you everything that you're supposed to do. If you do everything right, and then it's going to give you an idea of how high your levels are. The issues with these is that it's only a glimpse in time for 2 or 3 days that you take that test. So you could do a test and everything comes back wonderful because you've had the past week be nice and dry. Well, then after the test is over, you get a lot of rain, and if the slab starts to get wet, you'll never know. So everybody did everything right, and if it's an open system, no vapor barrier, or just gets re-wet, your slab could still be crazy high and cause you all kinds of grief. What's done in the industry primarily now is a relative humidity test. So what you do is you drill a hole into the slab, 40% of slab depth, and you put this little probe in there. What I recommend, if this is a very high profile, high fast pack job, you're already having job meetings, you're having your flow charts on the way everything's going. If you have people include in this, whether it's the GC or the flooring contractor, I want you to come back and I want you to put the probes in and I want you to test it every month and plot that on a graph. And then what you could see when they're getting close to putting the floor covering in, you should watch this graph and the chart numbers should start to just steadily go down. You should see your relative humidity numbers coming down, down, down to what the floor covering manufacturer says is acceptable. If that happens, you know you're not going to have any problem. If you're watching that chart go down and all of a sudden there's a spike, well, that tells you something happened. What that is, you'd have to find out. Was it a sprinkler leak? Was it a roof leak? Or you shouldn't see any spikes with that. But if you do that testing early on and throughout the project, you can ensure yourself at the end of the project, when it's time for floor covering, you're not going to have a problem. So that's something we recommend for you guys a lot. If you think there's a problem, a silly thing that you can do is this little piece of plastic, you tape it down, and if you see this dark spot, then it tells you, hey, you have a problem. We don't tell you, it doesn't tell you the extent or how bad it is, it just tells you there is a problem. The big limiter with this is if you don't see that darkness, it doesn't mean you don't have a problem, but it's a cheap, quick, easy way to say that maybe you do. This thing right here, it's more for wood, but this tells you, hey, there's a problem, let's do a real test like that, or maybe this. Most of the industry is getting rid of this. Another massive limiter to that test is it only tests the top inch or less of concrete. So all of these tests, you need to have the building enclosed as per ASTM, and the HVAC is supposed to be on, and it almost never is. So most of these tests that are done are pretty much invalid anyway. But if they did them the right way, this is only testing your top inch. So you could have your top inch, if you remember the sponge analogy, the top of the concrete's dry, the bottom is wet, and this thing's telling you everything's wonderful. But down here lurking is all this moisture that's going to cause your floor covering all kinds of grief. Sure. So we did all the tests, and now we have to figure out what we need to do to fix this moisture problem before we put all the floor covering in. This tells you a concrete surface profile, the look that we want of the concrete before we do the fixes. The way to fix concrete and get rid of this dark junk or adhesive residue or sealers is you can use a big grinder, a surface grinder like that, before grinding, after grinding. So nice, clean, white concrete. This is probably the most common and one of the best methods. It's called shot blasting. It comes with a giant vacuum next to it. It has a little metal shot and this little hopper that shoots at the floor, and it profiles the floor, cleans the floor, and gets everything out of the concrete and off the top of it. Extreme cases, we have something called a scarifier, a rotating drum with teeth, and it chews up the concrete. So if you have a lot of, we've seen, have you ever taken a third floor roof and converted it where you're going to add another 3 or 4 stories, that kind of thing? We've had hospitals where they've done that, and the old roof was like a tar kind of substance. So you want to make sure that you get rid of that. So the best way is you get really aggressive. The fastest way is to do this. So these are some of the methods to get rid of it. So once we get rid of it, how can we fix it? How can we stop the moisture from being a problem? The most recognized is 2-component 100% solids. That's what this stuff is. You put that epoxy down on the floor after it's been cleaned and profiled. Any amount of moisture vapor that's coming up through there is slowed down to the point where it's not a problem for any floor covering. So you can put any floor covering down once you treat the concrete with the epoxy. The thing to keep in mind when people are throwing numbers at you and asking for change orders, this is only one part of a system. So if you have high moisture, you have to do that, and then you can do this. But now you have a non-porous floor that might not even be perfectly flat and smooth for your floor covering. You would then put a primer and a self-leveling product on top of those. That then allows you to put whatever you want on top, any kind of flooring on top of that. Another product is this 1-component urethane. The 2 things you're going to see primarily is these 2 products. This has no limit, so it doesn't matter what levels of moisture vapor you have. This will fix anything that you have. These systems that have a limit, where I look at those in the industry is if you're doing new construction, this might be a solution for you frequently, whereas I rarely say that. This is where you have new construction, you pour the concrete, the schedule is so quick, the concrete just hasn't had time to dry out. You know it will, but it just hasn't had enough time. This gives you enough time to let the concrete dry out. It's good up to, say, 95% relative humidity, which is a pretty high number. This has no limit. But if you were in an older building with a renovation, there's no reason in the world the moisture level should be high. So if the levels are high in an older building, then something's wrong. It doesn't have vapor retarder. You're going to need a system without a limit. So for you, you're probably going to see this a lot, or it could be used a lot for your jobs, which is good because it also brings the cost down. This is the most common thing in the industry, and to do something like that, you're probably in the range of $5 to $6 a square foot. This is going to come down probably $2 a square foot. So it makes a big difference in cost. This is something I think is silly. We do make it. A lot of people make it, but it's just a roll membrane that if you have high levels of moisture, the concrete has oil in it or something, you could roll out the sheet. It allows the vapor and everything to breathe underneath the system and then exit out the sides, but it's not permanent. These systems are permanent. This, you're going to pay for it once, and then when you go to demo and renovate and put new floor covering, you're ripping it all out and doing it all over again. So it doesn't take long before that cost, the added costs add up to exceed what those are. Moisture, again, you can have it certainly from sprinklers and floods, things like that. Hydrostatic pressure is kind of simply this. You have a subfloor in the basement. You have your water table down here below it. These two never meet happily, and we don't have any problem other than the vapors coming up and causing the issues we just talked about. If for some reason, like let's say the backfill wasn't sloping away from the building, it was directing water to the building. Let's say you have a lot of rain. Let's say you have a horrible site condition. If the water table here starts to get higher than this slab, then this water is going to find a way to get into this space. So it's going to get into that joint or through cracks. Usually hydrostatic is under pressure. So as this column of water, let's say, goes up, it's creating a head pressure pushing down. And the higher this is, the greater the pressure is pushing out of here. So at a bad example of this, you'll see a little geyser just coming up through cracks through a hole in the floor. I haven't seen it. Hopefully I never do, but it could happen. What do some of these moisture issues look like? You know, we keep talking water. We're all thinking this. It's a gas, it's a vapor. We don't see it, but it causes this stuff. You'll see blistering in the floor. You'll see a beautiful floor installation. You come up with a design, you win an award, and all of a sudden you see this develop and you see that develop. You're like, man, what's going on? It's this. This is in the industry by far. That's the biggest problem. Contaminants. In many ways, contaminated. Blah blah blah. Okay, so this is a table of some of the contaminants that you would see on a job. The first one right there, almost every single slab that we do, they're putting a curing sealing compound on the concrete. And what that does, back in the day, they used to wet the concrete, put burlap on and keep the burlap wet, and it would stop the concrete from drying, the top drying out like that sponge. Now they put a spray compound on it. It stops the moisture from escaping too quickly, and it stops that top from drying out and curling. So those sprays, those curing compounds, the moment you use those, which is used on every single job, you avoid basically every single warranty in the industry. So all the floor covering you're putting down in all your multifamily, more than likely none of it has any warranties as we speak, every single square foot of it you've done. That sounds scary. I would ask you how many problems have you had? Probably none or very little. So it's done all the time, but a lot of these curing compounds are film forming, and they wear away with foot traffic over the duration of the job, or the UV rays of the light of the sun breaks it down. If you're in the middle of the building and there's no UV rays, or there's a palleted drywall and you can't walk it off, maybe that spot's heavy, maybe you can have a problem. Not a big issue, but it is a point. We've seen paint and pen markings. They lay out wall, locations on the floor. We've seen that telegraphed through sheet vinyl. So you pick a nice white sheet vinyl, nice little lovely alpha. You could have that come through the sheet vinyl. Oil and grease, unless you're doing a renovation, probably not going to have a lot of that. Your biggest thing with this would be if they're putting a sprinkler system in, and when they're cutting the pipes, the threads, they have oil. They should be protecting. How do you put in there any specs at all that they need to protect when they're cutting for sprinklers? No? So you just hope that they do it? No, I'm not being a...
No, I don't know.
That's something for your sake that you might want to consider, is that if you have sprinklers in your buildings, I would consider adding something about that. Asphalt tar, again, unless you're doing a renovation, probably unlikely. This is a real common thing, chemical adhesive removers. Where are you going to see that? If you did renovations and they did chemical abatement, so you had asbestos tile with 9x9 tiles, they're going to use chemicals sometimes to remove the adhesive. Any kind of adhesive remover if you do it right, you shouldn't have any problems with your project. Even if you do it right and the concrete, like let's say you do a renovation of a multifamily, you use an adhesive remover to take all the adhesives from the old carpeting or whatever flooring. If the concrete ever develops a crack, and it's happened once or twice in the industry where we have cracked concrete, the adhesive remover gets in that crack. You can't clean that out. So I've seen wonderful installations where the floor covering looked fantastic and everything was bonded, but every single hairline crack showed through on the sheet vinyl as a brown stain. So one thing you could certainly do with respect to that is if you ever got into chemical abatements or anybody's ever talking about removing or getting rid of anything, make sure it's mechanical. They either hand scrape it or use grinders or shop blasters or something. You should when you hear a chemical remover, you should run and scream and say, absolutely not on my job. This is well, we went over some of these. These are the sprays that they put down that we talked about the warranties. These are the pen and paint markings that can telegraph through here. Oil and grease, again, you're not going to see a whole heck of a lot. One thing with these, the sweeping compounds, very common. They put it down on the floor to control the dust from going in the air. If you have a certain compound, some compounds are based with, it's basically sawdust covered with oil. Some are covered with like a wax. If they put it down on the floor, use it and get rid of the dust and get rid of everything, you don't have a problem. If they start sweeping everything and then leave it in the pile and go to lunch, and then they roll scaffolding over it, and everything gets ground down into the slab, then you can have a problem where that sweeping compound pile was. So on your level, I don't know how you can control that. You just kind of hope that it doesn't happen, and then if it does happen, you hope you can bring enough people in and say, hey, knucklehead, this is what you did, and it's your fault, and fix it. Unless you're redoing roofs, probably not going to see that. We talked about chemical adhesive removers. Cures. We kind of went over this. If you have the contaminants in the floor and it's just mostly topical, you could do mechanical abatement, which is shop blasting, scarifying, grinding, sanding. Sanding is usually not very common, but shop blasting and scarifying, shop blasting and grinding are the two most common methods that you always see. All right. Cures. And again, we talked about if you have those issues, two-component epoxy is pretty much the best for moisture. You could use another thing for what you do. If you have a bad gypsum core in your multifamily, and your option could be let's remove it over 16 floors, which is probably not high on the list of things to do. Is there a way to fix something that was overwatered or they put too much sand in? There is. You could take this epoxy that is meant for stopping moisture, but we use it now and we call it a consolidator. So we get greater coverage, so the costs are certainly going to come down, and all you have to do is slather that stuff on a weak floor, a weak gypsum floor, and that'll stiffen up the top surface. It sure beats ripping it all out and redoing 230,000 square feet. If you have a slab that has multiple different porosities, there's new concrete, there's old concrete, there's adhesive residue, there's blah, 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 you can coat it with stuff like that and then unify the porosity so that then you can then repair it with a self-leveling. We talked about the sheet that I'm real fond of. This is kind of a last resort, and I think in 20 years we've ever only done that once on a church in Pennsylvania. If your slab is so bad, let's say it was an old garage and they just did oil changes, or it was we had a factory once where it was a glass factory, and they had steel wheel carts that had loads of glass, super heavy, and they had to put, I think it was steel or some kind of iron shavings in the concrete to make the concrete harder. Apparently it worked. The concrete was in great shape, but when they then converted that space into office multi-use space, they wanted to now put sheet vinyl and whatever into it. Well, all those bits of metal that were in the concrete or ferrous, they're going to corrode. If there's no floor covering on top of it, the moisture vapor coming up through, breeze, and everything's fine, and there's never an issue for decades, for centuries. Now you put down some VCT or some LVT, you put a piece of plastic on this floor, now that vapor can't go anywhere, and now that ferrous metal oxidizes, rust, and then it starts to just bloom, and your concrete can just, nothing would stick there. It's a disaster. What you do, I don't think they're going to have to do that. So probably not going to have to demo much concrete. Movement, that's your biggest issue, for what you do. Precast, I mean, the way you designed it, I don't think movement's going to be too big of an issue for you. movement. So again, for you with multifamily, there's not a whole lot of settlement on the 16th floor, but you know, you might have some compaction issues on grade or something. You could have some steel issues, and you can have deflection, certainly without a doubt. Mixed substrates, we talked about that before. That's, you know, wood meeting concrete, probably not real common for you. And deflection, that's your biggest enemy. I don't know if somebody had a bad day and they under-designed some steel and then you have a little bit of sag or whatever. It happens, it's very common. You can control it, but you can, more importantly, you can fix it. Not fixing it very much with concrete, regular concrete, but these products you can. When you see movement, a lot of companies like ours, we're going to ask you, is this joint active or is it dormant? If you have cracks in all your rooms in the 16th floor, if they're all straight line cracks, north, south, east, west, that tells us it's movement. And why that's happening, you guys need to figure out. We can give you some solutions, but we want to know, is that movement done? If the movement's done, then we can cover it and everybody can move on and there's no problem. If the movement's not, like if you tie an old slab to a new slab, but we don't dowel it together, that would be considered an expansion joint. Real expansion joint is going to be, it's there to move, and if you don't stop it from moving, it's going to move and you're going to have all kinds of problems. We get a lot of, I don't see, you don't have like column diamonds. You'll have them, but they're not going to be in somebody's living room, right? Like you have it in the basement or something. So every now, you'll see that a lot in hospitals, and how we have to handle that is you could take patch and put certain fibers in the patch to stop those diamond columns from cracking the substrate and coming through the floor covering. But for you, probably not a big issue. Movement, you're not having that. Let's see here. If you have, say, deflection, and somebody's going to say, I need a big old change order from you, and you need to figure out how in the world, how much is this going to cost? How do you determine how much product is needed to fix it? This is a nifty little map. Let's say the orange represents the lows, the purple represents the high. If all of these are columns, and you just had massive deflection, the way to determine how out of whack everything is you come in, and this little laser level here, there's multiple ways to do it, but these are all grid points here. You could do it every foot, 3 feet, 4 feet, 5 feet. When there's problems of deflection, you see a lot of general contractors will come in, they'll lay out a grid every 10 feet. When they lay out a grid of 10 feet, then they can take all the points, add them together, and average them out, say, okay, you're out of whack on average 5/8 of an inch. So you're going to need 5/8 of an inch of stuff to fix this floor to get you back to ground zero, flat level, and everybody's good. At a 10-foot grid, the grid is so far apart, you could have stuff between the 10-foot grid that they're not catching. So if you ever have a floor that's really nasty, you probably want to suggest a 5-foot grid. That gives you a really good idea of what's going on with your slab, and you can get an accurate estimate of what the stuff would cost. Cures, let's see, reinforcing. When you have an actual expansion joint, you are supposed to honor it with these big, ugly, hideous expansion joints that you love to use in design, right? You put them in all your junk. So if for some reason that doesn't appeal to you in somebody's living room, you can go a route like this. If you don't honor it, you pretty much lose any warranty anyway, but we've had tremendous success with taking patch, putting it in a joint, reinforcing it with a fiber. They used to use this old metal lath to do that, but when you put reinforcing like metal or fiberglass, this stuff has much greater strength than that, believe it or not. It really, what happens is it doesn't stop any of the movement from occurring, but as things are moving, the fibers are tying everything together, so it's all going for a ride together and it's staying together. Without the fibers, the little piece could come up, and then maybe it goes back down. I might do that a couple of times, but eventually that piece could twist and turn, and then it doesn't fit down like a nice jigsaw puzzle piece should. And next thing you know, you see a line that looks like a mole dug a hole through your floor. So, so reinforcing meshes could really be your friend. Probably not a big option. Demolition, you know, if the floor is really nasty, you could take it out. This, I believe, was a job in England that was just horribly nasty. You could put layers and layers of mesh on floors that are just horrific. I don't see you ever running into this or needing any of that kind of stuff. Testing. So if you have movement, you want to trust some guy that has not had your education and has just been putting down floor covering for the past 20 years, or do you want to go with science and say, hey, this may seem like old science, right, dragging a chain, but if your floor, the concrete is poured, let's say it's a cast in place scenario, if they put too much air in it, or it gets frozen, or something weird happens, and there's all these hollow spots. It's all spalled. Maybe you see some little visual mark, but you want to know that that floor is solid. If you take this chain and drag it over the concrete, you could hear a hollow spot in concrete. If you tap it with anything metallic, you could hear the hollow spot. So if you see something, why don't you tell your GC to go grab one of these off the job box, and he can sweep the floor with it, and then you can hear and say, okay, something's wrong with this concrete. You better get that fixed. This tells you how soft. It's a German test. It tells you how soft the floor could be. These are the relative humidity tests. This was in a water plant in Allentown. They had so much moisture coming through their floor in the water treatment plant that the glue re-emulsified and filled up these with like liquid glop in a water plant. That's just kind of funny to me. This, you want to say, okay, you said active or dormant crack. How in the world would anybody know? They make these nifty little strain gauges, and you could tell if there's movement or not. So if you have a crack, I mean, this is usually for walls, but you could steal this and put it into our industry and say, hey, you know, we've had this being on here for the past 2 months and it hasn't moved a fraction of a millimeter. That's a dormant crack. Let's not worry about it. Or you could see this thing bouncing back and forth like a spring. You know, you got a problem. Sometimes we just want to know if the floor is absorbent. Just put some water on it and check for absorbency. This is a common test that, or it's a test that I wish was common. This is a pool tester. You epoxy this little piece of metal on the floor. And why you would do this is if your floor, let's say the gypsum we talked about before, we think that maybe the gypsum's on the weak side and we want to know if it's weak because it's really rough and we want to repair it. If you want to repair it, if people like us that put stuff on top of it, we have certain minimums that the concrete needs to be, a certain strength that it has to have. So if we say it needs to pass a pool test and have a minimum of say 75 PSI, all you do is glue that little piece of metal, connect that contraption, dial it until there's a failure. Well, normally it's going to fail around 200-300 PSI. It's going to rip the concrete apart and everybody's fine. If you just pop this little epoxy piece of metal off of the gypsum and it pops at like 25 PSI, you know you have something really, really weak. Nothing's going to be sticking to it. Carpet, flooring, you're in trouble. And I would say then thank you. That is primarily everything we have. Now is when we could open it up for questions if anybody has anything.